Hello, I'm Tom Burniece. I'm a volunteer at the Computer History Museum in Mountain View, and I'm here with Lary in Colorado Springs,
Yes.
and we're going to do the second half of his oral history interview we did in August 2015.
Right, so it's not quite 3 years.
Yeah, we couldn't quite get him to come out to California, so I decided to go to the mountain.
Older but not
Literally,
wiser.
I figured we were at the mountain. So, anyway, we got about three and a half hours for the first half, and we worked our way up through his early time at growing up, where he grew up, got an interest in computers and so forth, and got through the early days at DEC, including one of the architects of the VAX. And there's early time in Colorado Springs, and we were basically up to about the point where we've talked about the HSC in some detail, but not necessarily completed. So I want to just start out, Richie, with an opportunity for fill in the blanks. I know you've now looked at your whole.
I finally looked at the transcripts from 2 3/4 years ago,
So,
no, they're fairly good. I don't think there were major holes, an anecdote here and there that flitted into my memory and flitted out again, so it's not worth going over here. It basically took us up to the shipment of the first digital storage architecture products. Right. And jumped around and rat-holed the way I usually do, so there was some stuff in the future, but it kept coming back to basically sometime in the early 80s we had this suite of disks and controllers that implemented storage on a VAX cluster and on individual servers as well.
Right, we ran on multiple buses,
And
the
ran
BI
multiple
bus,
buses and had
unibuses
all the right characteristics of failure tolerance and performance and all that good stuff, except maybe the characteristic of price, which digital was always high on.
All right, so anything else that you feel you'd like to fill in about the digital storage architecture, DSA, any of the people that are involved in that, the HSC or that whole architecture? We did talk about Mike Riggle right at the end.
We talked about Riggle and that'll come up some more because it was an interesting time for Mike as the 80s turned into the 90s, and digital went through a kind of corporate crisis in several areas, and storage was one of them.
All right. So I'm going to ask you to backfill one very interesting little piece of history because we're going to interview her next.
Yes.
And that is, how did you end up? First of all, I know how you got introduced to Ellen Oliver because we actually, Barry Rubinson and myself, actually hired her into DEC as a PhD in relational database, and somewhere around 1982 or 83.
Yeah, I think she showed up in Colorado late in 81.
And we're going to do an interview with her later on this afternoon. You're now married to her, but the question is, how did you happen to really develop a relationship with Ellen and eventually marry her?
Right, okay, so I was married at the time Ellen came to Colorado. And sometime around 1980, not to get into too many details, I wound up falling in love with somebody in Massachusetts, where I was spending quite a bit of time because of a lot of the digital storage architecture stuff. I actually wound up becoming infatuated, obsessed, essentially, with somebody in Massachusetts. And while it was not it was a platonic relationship, I was like emotionally whacked out and came back to Colorado and told my wife, Barbara, that I was in sad shape because I really didn't know how to handle it. I'd gotten married early, I was a nerd, my emotional intelligence quotient was down here somewhere. And that set kind of a chain of events going. It caused Barbara to question her role in the relationship, what the relationship meant to her, which caused me to, our relationship had been fairly good, but both of us were interested in kids, but neither of us wanted to pull the trigger on having kids. I was 32 now, in 1980, which was kind of a symptom that we didn't feel completely at ease. And then, so this exposed a bunch of fault lines in the relationship, which wound up in late 82 with us separating.
That I remember very well, because I remember you walked in my office and saying you're going to get divorced.
Right. So meanwhile,
you're not a happy camper.
Sometime in late 81, Ellen Oliver a request to interview Ellen Oliver shows up in my inbox, right? I'm on her interview loop. So I go and interview her for a job as the database advanced development manager in Colorado, and the interview went well. She had impressive credentials, especially considering, that she put herself through graduate school with 2 kids in tow and all that. And I don't want to tell her story for her. You'll get it.
Very interesting story.
And she wound up getting the job, and moved out to Colorado. And since I was kind of a roving techie, right? I did some work with the database group. In fact, afterwards, this was after actually Ellen and I had gotten together as a couple. Ellen and I used to travel out to California to meet with a group in National Semiconductor, and we designed a sorting chip with them, right? So this was our first kind of technical joint venture, Ellen's and mine. But before that, Ellen, who was a single parent, kind of integrated herself. There were a group of friends that would hang out in Colorado and go out dancing on Friday nights, go to, luckily disco was fading, but it was, go out to clubs and bars and dance and have a good time, and Ellen liked to do that, so she attached herself to the group. Not everybody in the group was married. It was a bunch of some married folks and some single folks, and so, and so we became friends. She became friends with me and with my wife, and when the marriage ultimately did collapse, she was one of the shoulders that I used to cry on, right, about the sad state of things. And after a certain amount of that, I got tired of crying on her shoulder, and I asked her out.
Good plan.
Huh?
That's a good plan.
Right. Until then, that was February of 1983, I guess, when I finally asked her out. We celebrated as an anniversary to this day. Before then, there was really nothing romantic going on, although, random story, she threw a Halloween party in late 1982, a costume party, and I did show up at the party as a 6.5-foot penis. But I kind of walked into the room all bent over. I had this headpiece that I had made, and I asked somebody to stroke my head, and they did, and I straightened up, and everybody laughed. But anyway, but that wasn't deliberate foreshadowing, is what I'm saying, right? At that point, Ellen was just a friend who was throwing a party. So sometime in 1983, we went out, and basically things moved very quickly after that. Sometime in the summer of '83, when her kids went to their biological father's place in Syracuse for a couple of months as part of the custody agreement, she moved in. And then sometime on July 3rd of 1988, which will be 30 years ago in a couple of months, we got married on our back deck.
I was there. I was there.
So, having built a house together and incurred the resulting mortgage together, we figured we might as well be married. And we've been, a couple for 5 years. So, and you were there.
And you kind of became father to her kids.
And I entered an entirely new and very rewarding phase of my life. Yes, Ellen is responsible for whatever raise in my emotional intelligence there's been in the last, 30 or 35 years, because she's got plenty to spare.
Absolutely.
So,
Well, that's great. Well, we're going to let Ellen tell her side of the story.
Right, and exactly. And I do remember you talking to Gordon on his sick bed or something.
Well, I talked to Gordon and
telling him that, hey, it was okay, I was hooked up now.
Yeah, no, it's absolutely true. Gordon had a heart attack out in Vail or Aspen, and ended up getting triple bypass in Denver. And
right.
I went up to visit him right after he got out of there, and first thing he did, when I walked in the room, said, "Hi, how are you?" I said, "How's Richie?"
Yep.
And I said, "He's fallen in love." And he said, "How'd you do that?" So I didn't do that.
Well, you helped
But
hire
never held
Ellen.
Oliver,
Yeah.
and they're now a number. And of course, that was 83, I think.
Yeah, it was.
Might have
It
been
was.
84, but I think it's 83.
It
So,
was.
So absolutely. So anyway, let's move on to the rest of the history of your history at DEC. And so it basically covered the DSA and the VAX cluster world, but let's now move into what became called StorageWorks. Which
Well,
was a
we should.
significant change, right?
There's a long period there,
Okay, go ahead.
which comprised the rest of the 80s, because the HSC shipped in 83,
Right.
right? And the UDA and the QDA were both out by then, and we had, I think, 2 discs out by 83, maybe the RA80 and the RA60, which was a removable
Right.
disc. Also a massive, I forget, 60 megabytes or 80 megabytes or something like that.
The RE60 was 205 megabytes.
Oh, was it? It was bigger.
Yeah.
Okay.
Yeah. Yeah.
And then
five
and then
disc
we
pack.
did and then the successor to the 80 was the 81, which was
Right.
a healthy 450
Something like
megabytes or
that.
so.
And we had an RE2.
Right. And then there was a pause
Right.
because the 80 and the 81 both came from, I think, products that were designed for the industry, or at least they came from the same chassis, the same basic design, and then we decided to go to a 9-inch
Right.
form factor. That took a while to do the brand new mechanical engineering,
We
etc.
actually did two. We
So-
did an RE9. We did a 9-inch and a 5 1/4.
Right,
And they
right.
were,
We did a 72, which was a 5 1/4, and the 90, which was a 9-inch. But the rest of the 80s really were technically boring, with a couple of exceptions. It was a consolidation thing. We just come out with this new architecture. Now we had to flesh it out.
Okay.
We were still in a position where we were a proprietary storage group that was part of a proprietary systems company, right? So our one customer was the digital systems group, right? And of course they kept coming up with new system buses. The BI bus came out in around 1986, and something called the XMI bus, these are backplane buses that would connect one or maybe a couple handful of CPUs to a bunch of backplane type peripherals, with then the wires would go fanning out to wherever. And of course we had to produce storage systems for those. And one of the challenges we faced, not an interesting challenge, but it was a challenge, is both of these buses were a lot faster than the Unibus and the QBus. The Unibus and the QBus were like fundamentally 1 megabyte per second range buses. The BI was 10 or so megabytes per second, and the XMI was maybe 40 or 50, I forget. The numbers are out there to find, megabytes per second. And the architecture that we used to build the UDA and the QDA was not good enough for those buses. So we had to do some invention, right? Not big architectural kind of invention, but down and dirty engineering. How do we build a controller? So somewhere around there in the early 80s, a professor at UCCS, a guy named John Murray, was offering the Carver Mead Lynn Conway Introduction to VLSI Architecture course. And I took it, and it was a great course, a lot of fun. You got to build something and hand it in to be fabbed, and you came back, and then you got to stick probes on it and make sure it worked and all. And coincidentally, right around that time, I got involved in this is around that time, meaning the mid-80s, I got involved in 2 chip projects. One was this joint venture with National Semiconductor, which I think never really saw the light of day. The chip was produced, but it was not, this was when databases were going to conquer the world, and specialized hardware was going to make databases run fast.
We actually, at that point, and the reason we started the relational database group in Colorado was we were going to make a database machine out of the HSC.
Exactly.
Turned out the HSC, which was a block device, was not very well suited to becoming a database box.
Exactly, and we were feeling our way around, as was everybody in the database space at the
And
time.
we eventually killed that, but that started that group.
And one of the things we knew that you needed when you had large amounts of data was to sort fast.
Right.
Okay?
So this is a sort chip.
And so this was actually a sort chip. This was something that you passed the data through the chip, and you potentially passed the data through multiple times. So the chip was a processor surrounded by a data flow type sorting engine,
Okay.
right? It was, and the fun part of it was that I got to help do the hardware design and picked up a little of I forget, maybe it was Verilog, one of the software-like hardware design tools.
It probably would have been
And at the same time, because of the need to build these faster controllers, we hooked up with the digital VLSI group out of Hudson, and they lent us a team of 4 chip designers, and we showed them the problem, and between us we designed a VLSI chip that it was kind of like when I talked about the HSC controller, I talked about these K-dot controllers with the AMD processors in them that would handle the disks, and then our processor would be a traffic cop. This was kind of a K-dot controller on a chip.
Okay.
But because of the limitations of VLSI at the time, it was a lot dumber than a K-dot processor. And in fact, this chip couldn't even add. It could count, but it couldn't add, right? So it could follow pointers though, and so the challenge was to design a set of data structures, this thing that I referred to as a hardware-software interface, so that the main processor in the BI storage controller could set up data structures in memory, and this chip would go and kind of scan them and peruse them and keep an eye on the spinning disk drives and go, oh, this block says that when you get to this sector on this drive, there's something to do, and look at that, I've gotten to this sector on this drive, let me go do it, right? And so that was actually a lot of fun, building an interface to a processor that was radically different than any other kind of processor. It couldn't add.
Did that chip actually end up in the BI controller?
That chip
BEA?
ended up in the BI controller, and I believe we may have even reused it in the XMI
Okay.
version of the controller, because with that chip or multiple instances of that chip, we could be transferring from multiple disks at once, whereas the UDA and the QDA, pick a disk, transfer from it, and then go find something to do on another disk. So again, this was.
And that was the chip
But this
that you
isn't.
actually
But this
worked
isn't.
with
This
Ellen
isn't
on,
the super. No, the chip I worked with Ellen on was the sorting chip with
All right,
National
all right,
Semi.
okay, they're two different
This was
systems.
just part of the. Okay, you built an architecture. Now you got to fill it out.
Yeah.
Right. As I said, it's kind of consolidation. Right. Handle the next set of disk drives. Handle the next set of processor architectures. Eventually, put a faster processor in the HSC 50 and call it, I think, the HSC 70,
Yep.
and then put a cache in it and call it the HSC 90. And part of it is kind of milking, right, a classic kind of milking strategy, incremental improvements to the product that convince people to upgrade or make it more desirable against the competition. And part of it was, as I said, keeping up with our customers on both ends.
Right, oh, yeah.
Because we were in the middle between the guys developing disk drives and tape drives, because we handled tapes. So we took the K-dot disk and reprogrammed it, no hardware changes, to be a K-dot tape, and brought the guys in from Shrewsbury who developed tape drives. And one of them, the famous story was a guy named Paul Kinzelman, who was a good software guy on the tape side, but he also was a vehement anti-smoking advocate.
I think I remember this.
Okay.
Yep.
And this was the early 80s in Colorado, and we had a couple of smoke-filled conference rooms which were designated smoking rooms, etc. But the lab, because of its good ventilation system, we allowed the techs and stuff to smoke in the lab, and he objected to that. And rather than subject the techs to, hey, you got to smoke, leave your bench, go to the smoking room, we built him something called the Kinzel cage.
I remember this.
Out of plastic strips, the kind that you see sometimes in front of supermarkets to
Right.
designate the treated air from the untreated air, and put positive pressure in it so that the stuff was always blowing out, and that's where he stayed in the lab. So we got the tapes, and then the one interesting thing that digital did, I was involved in this in a oversight kind of role and an integration role, but I was not responsible for the main concept, which I guess we should credit a guy named Marty Chakowski with, was we built a solid state disk.
Yeah,
that
you
was part
absolutely
of
were early involved in that.
the storage architecture.
Talk about how that was architected.
And DRAM was horribly expensive, and Flash was a non-starter. It didn't really exist at the time,
Yeah, it
and
really
it was
didn't
terribly
exist.
slow. And it wasn't Flash; it was EEPROM, and you programmed it exactly once, which isn't a good characteristic for disk drive. So we needed to be able to get the price down over just a big chunk of memory, because if you had a big chunk of memory, other than the fact that it was persistent, it would be better off in the processor next to your applications than out on a long wire connected to a processor that itself was out on a long wire from your application. What they did was they realized that they could use all this great ECC technology that we had developed for disk drives and use that technology to take inferior memory chips, what they called floor sweepings, the stuff that failed the final tests at the memory manufacturers, but didn't fail it in the sense of the chip was absolutely dead, failed it in the sense of the chip was not perfect.
Had a lot of bad.
Okay,
bad
it had a
bits.
lot of bad bits, it had sometimes bad areas, we had some rules for how much of the chip could be bad, etc. And the idea was that we would go to these guys and say, we will take those chips, which are worthless today, off your hands for a fraction of the price of a good chip, but still much more than the cost to you of binning those chips from the true dead memory chips, right? And I think the ultimate price that we kind of agreed on with them was it would be about half the price of a good chip. That's, you need to talk to Marty about it. And so we took those loser memory chips and packaged them with an ECC and turned it into a actually very competent solid state disk drive, which, you know, in terms of today's performance of flash devices wasn't really very hot, but in terms of the ratio of its performance to the disk drive performance of the day, which was again maybe 50 to 100 IOs per second, I think this thing could do 500 to 1,000 IOs per second. And as VAX had become really successful in commercial applications, you become a victim of your own success. Your users go, this is great, but it's not fast enough now. Now I'm putting all these apps on it. And so we sold a whole bunch of those.
So there was really two basic concepts in the solid state disk. One was using scrap memory
Right.
with a very powerful error correcting code, which turned out to be the 170-bit Reed-Solomon error correcting code that Mike Riggle's group had designed for all the controllers, including the HSC, which is used to be almost a runtime, real-time error correcting code, and put the scrap memory behind that, and that then resulted in a memory that was not persistent, but was very fast and very low cost, or relatively low cost. And then we put a hard disk and a battery behind that
Right.
to give it the persistence, and put that in a box called solid state disk. We weren't the first guys in the world to do it, but we were like second or third.
Right.
And
Yep.
The really interesting
I think
part about-
IBM had done that probably before
Right.
us, but they did it in a different
I
way.
think
They
Storage
did it
Tech,
as a kind of massive memory that hooked into
Yes.
the CPUs with a special
Yes.
bus, not as a general storage peripheral.
And Storage Tech had also done something similar. But anyway,
Yep.
bottom line is it vaulted us in a really interesting position. We now became the online transaction processing part of the big banks, the Bankers Trust, the Citibank,
Right.
and so forth. And because we also had, with the VAX cluster, the ability to be able to run shadowing multiple copies deep, so you could have a copy across a river, that kind of thing.
Yep.
So talk a little bit more about that whole deal and how big a thing that was today.
Right. So yes, one, it got us into the high performance commercial market.
Right.
There's another aspect to it which has a certain element of foreshadowing in it, so I'll mention it, which was that when we implemented shadowing, mirroring, RAID 1, whatever you want to call it, we discovered that a lot of users were using it for reasons that we hadn't anticipated. Okay, and there were two of those that I can think of. One is that when you mirror something, whenever you do a write, you have to write both copies, of course, but when you do a read, you can pick a copy. And so the performance of a mirrored set, when you were doing read-intensive stuff, was double the performance of just a regular disk drive, because you had two sources for your data.
Right.
And there were customers that were mirroring. They didn't need the extra reliability, or it was a bonus, but they were doing it for performance.
Yes, they were.
Okay, and they were doing it because these, quote, crappy old disks, right, big 14-inch platters, big arms relatively, just didn't have the right ratio of size, even though their size is minuscule compared to today, to performance for some applications. So they were using shadowing to do that. And the other thing we found was that customers were using mirroring, and they would deliberately break their mirror to get a stable copy of their data to back up. So they break the mirror set, back up from the one of the copies while the other copy stayed online and serviced their application, and then when the backup was finished, they bring that back in to the mirror set and painfully rebuild the entire mirror set. But by doing that, because backup utilities, because there were no snapshots. This was the customers showing us what the future was.
Yeah,
and the future was better performance to size ratios and snapshots, right? And we saw it and we internalized some of it, and we didn't internalize some of it, okay? That was, in fact, I believe that at least in the VMS side, they allowed more than two. I don't think we ever got to more than two members of a shadow set, so that you could cut one out for your backup and still be redundant, right? So we played into it a little, but what we didn't play into was the idea of, hey, isn't there a lighter weight way of implementing a frozen copy of your data than to break a mirror in half and then painfully rebuild it afterwards, right? And we also we did get cache into the HSC. We did not get cache into any of our backplane controllers, and we didn't, even though we had done all the simulations on it and we knew how good it was, we didn't get write back cache into the HSC, mostly because with the technology at the time, we were just too afraid of losing somebody's data, because there would have been one single box, one single HSC box that had the data. We didn't have good communication between a pair of HSCs. They did not pass data back and forth to each other. They just talked to the same drives, and when one of them failed, the drives would actually tell the other HSC that the first one wasn't talking to them anymore, and it would take them over. In order to do a write-back hash, we would need some kind of high-performance wire between the two HSCs so we could keep two copies of the cache data, and we never got that far.
Actually,
right? It was always a little too scary.
Right.
Huh?
Interesting. I was thinking we did get to almost an active system, but we never quite got.
Well, we got to no. The HSC was always active passive because of the nature of the SDI bus. One controller controlled a particular set of drives and presented those things. And so all that consolidation and kind of incremental improvement of the architecture kept us going and profitable, and of course we were riding the coattails of the success of VMS and VAX clusters and the VAX hardware, but it kept us as a very healthy business through the end of the 80s.
Actually, it went farther than that. If you take a look at the history of the HSC 50, which came out in 1983, and the last vestiges of HSCs running in production, it was well into this century.
Mm-hmm.
And the numbers that Bob Rennick has told me, I've never seen him substantiated any other way, but he's told me is that the total profit of the HSC itself over that 20-plus year period was over $1 billion, which is one of the highest,
I wouldn't doubt it.
most profitable products ever in the DEX product line.
Yep. And then, in fact, it wasn't. And then what happened, right, in the late 80s and early 90s, was the whole proprietary kind of stacked up model of things, right, where you controlled everything from the sand coming in to the field service guy who goes out and fixes the customer's stuff, started to decay.
Right, and
Right?
that's actually
And
where
the industry
were entering a little
became,
while ago, which
yep, the
changed
industry became
transition.
vertically segmented, and the open system philosophy was much better in that kind of vertically segmented world. Not because the products were better, the individual products were actually around the same, but the way they cooperated was much worse. But because it let a user pick and choose, and let the market drive each individual piece of that vertical stack independently, right? So that when you bought a processor from somebody, you weren't also bound to use their backup software and their database software and their applications and their languages and all that stuff, and their operating system. You could pick and choose, and for reasons that were really completely non-technical and very much market reasons, that's the model that won.
Well,
And digital was blind to that.
let's talk about the transition DEC did make.
Yes.
Which essentially is from the DSA architecture, totally proprietary,
Right.
to StorageWorks, which is almost totally open.
Yep.
And how that happened, and who some of the key players were in there. I know Shrewsbury had a lot to do with it, but who were the
Well,
key
so
players?
so Shrewsbury was in the business. There were two issues going on at the same time. One is the big discs versus little discs
Right.
issue, and the other was the proprietary interfaces versus open interfaces
Right.
issue. And the one of them, essentially, Mike Riggle was the champion of the large form factor discs.
Right.
Right. I mean, and when I say large, the Mike Riggle, authorized the creation of 5 1/4-inch discs. It's not that he was
Oh, yeah.
allergic to it,
And of course,
but he would look at the numbers. Mike Riggle was an engineer to his bones, and he would look at the numbers, and he would go, you're paying for the electronics, and you're paying for the motor, and you're paying for the interface logic, and you're doing all that stuff, and you get to amortize it over this many square inches of media versus this many square inches of media, and you can get better costs with the big discs, which was true, but there were market forces that were undermining his technical argument, and he was a little blind to those.
That's true.
And the market forces that were doing it was the guys who were building the 5 1/4-inch and later the 3 1/2-inch discs. Their volumes were so high that they created a whole ecology of suppliers who were super cost focused, because that's what they were competing on. These are commodities now, right? And so these guys would have the cheapest media and the cheapest heads and stuff like that. And we were there with our boutique big discs, but we didn't have the economy of scale.
And that was all vertically integrated.
And completely vertically integrated. And these guys were doing the same things that users were doing. They select their media from this guy because they had the best price and their media was good enough, and they select the heads from this guy, and everybody's racing that so that their technological improvements were not the sum of, did not come from one group. They came from the best of 5 competing groups out there, and the weakest of those 5 competing groups would go bankrupt, right? So, those were market forces that overrode any pure engineering argument, and this was not just true of storage. This is what sank digital on a number of fronts. The PC revolution was exactly the same, and when we finally did get into PCs, we built kind of boutique PCs that were a little different than everybody else's and a little more closed than everybody else's, and they had problems. So we were victims of our success, right? Success breeds hubris, and hubris breeds eventual failure, and that's you can see it happening today too. It's not like we were unique, or it's not like this disease isn't contagious. And so what ultimately started to happen was that our excellent storage products were starting to get priced out of the market. And it experienced, it manifested in two ways. One is that other people's systems wound up cheaper than our systems, so that our general systems started to decline. And also, it invited more and more people to try to plug us. Okay? And we had always faced that issue, and we had managed to keep people off of the SDI bus with a combination of, patents and trade and software copyrights and things like that. But ultimately, people were plugging us at a higher level. There were people who were building boxes that connected directly to the CI bus, right? There were people who were building products that connected to some of our other interfaces, and then offering these these open industry disks, which were, quote, not as good as ours, but good enough, right? SCSI was a terrible standard when it started out. It was a horror show. I was used to network protocols and things like MSCP, and I was appalled when I read the SCSI standard, because it was like their philosophy was, well, you can do it this way, or you can do it this way, or you can do it this way, or if you have a different way, just tell us and we'll throw it into the standard. Whereas network standards are, you don't have to implement this function necessarily, but if you do, you will implement it this way. Huh? Right? And when we had to educate ourselves on SCSI when we finally did make the transition to open systems, and it was very painful. We had to suppress our gag reflex.
In fact, they actually created a special version of it in Shrewsbury called DSS.
Right. The first thing that happened was, of course, we did the digital thing, which is we can make this better.
Right.
And we took the SCSI transceivers and the SCSI cable. There was our nod to interoperability, and put a completely different protocol on it. We put MSCP on it. We dual ported the drives, which eventually SCSI got around to doing, but the early SCSI drives were never dual ported.
Right.
But we did, at that point, that gave us a way to dip our toes into the smaller form factors. And I believe it bled over in that the RA72, which was a 5.25-inch digital storage architecture disk drive, came out of Shrewsbury, and was the chassis and mechanics and all were designed for a DSSI drive. And we took it and slapped an SDI interface on it, I think.
Well,
And got some synergy.
The RA70 was actually developed by Burt Miller in Colorado Springs with SDI on it.
Right.
It was a companion to the RA90.
Right.
But then Shrewsbury did the RF version of what it was, which was the DSSD version of it.
Right.
And then they eventually created their own HDD.
Yes.
So they were now using a completely different drive.
Right.
But they did create a version on DSSD.
And the other thing that did was, when we finally realized our problem, okay, Grant Severes, who was a really good high-level manager for managing an organization that was growing and exploring new technologies and making the selection choice. He gave Mike Riggle his head. He got the funding in the right places, et cetera. Was not as good a manager managing an organization that was suffering from cost overruns and kind of a leveling off of the sales curve, et cetera. He didn't like to cut, right? He was great at growth, but not that good at cutting. And so they brought in a number of consultants, some of whom didn't work out. And eventually, around 1989 or 1990, he brought in Charlie Crist as a consultant. And then, through a series of political actions that I just saw from a distance, so I'm not sure exactly what happened. It sounded to me like Grant reached for the VP of another group to do a lateral.
Yeah, he took on more responsibility. He took on the PCs.
Yes.
And some other pieces, and then Charlie.
Stepped into the job at storage,
right.
And
working for Grant.
Working for Grant. And Charlie Crist was a very interesting guy. He had a career at Xerox where he kind of revitalized their copier business against all this Japanese competition. So at that point, I was high enough up in the organization that I got to sit on Charlie's staff.
Right.
And so I remember going to his first staff meeting, because I hadn't really interacted with him when he was a consultant, because Charlie is a business guy. Technology is just a means to an end to him, right? And I remember going to his first staff meeting and coming out of the meeting, walking down the hall, and somebody asked me how it was, and I said, I've been at this company for 20 years and I just met my first businessman. Because digital would home grow its business executives from technical guys. They would send them to charm school, the 6-week MBA program or whatever it was at Harvard. It wasn't an MBA,
Those 11
but
weeks.
the 11-week cram course in how to read a P&L and other stuff. And poof, you're a guy with P&L responsibility now. Whereas Charlie just lived that stuff, and he was very upfront with it from the very beginning at the first meeting. He said, first he laid down some governance rules, because digital was a consensus organization, and he said, engineering, it's fine, consensus is fine. Business doesn't run on consensus. Here's the way it's going to work. We're going to have several ways to go on any particular thing, and everybody gets to talk, and everybody gets to argue for a particular way, and then I get to make the decision, and then everybody gets to line up behind that decision, right? Like, okay, well, that's interesting. That's actually the right way to do things at that level. And then the other thing he said is, I was brought in to make money with storage products. And he said, I can make money by making this a profitable organization again, or I can make money by selling it, right? And it doesn't really matter much to me. I'm not invested which one I do. Okay? Which, looking back at it, also makes sense.
Right.
But but set everybody in the room back on their heels. It's like, holy shit, this guy is not playing games. And he immediately started, talking about issues that were just way over my head. He went, we've got too many suppliers. Right? He had somebody, of course, count them up, and we had 300 and something suppliers for parts. And he said, you can't manage a purchasing department with that many suppliers. We're going to get down to 40 suppliers. And we're going to go buy these products from our competitors and tear them down and figure out how much they cost to build, and we'll figure out why we are so much more expensive, right? And the reason was that we were doing home manufacturing. Right, small batch artisan disc manufacturing instead of high volume, squeeze every nickel out of the product manufacturing, which was what the competitive market forces outside were forcing those guys to do. So he really completely restructured the business, and in doing so, de-emphasized the Colorado disc business in favor of the Shrewsbury disc business, because their products were more appropriate to be the base for competitive stuff. And he wound up butting heads with Mike Riggle. And Mike would use his technical expertise and his best technical arguments on Charlie, and it was blah, 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 because Charlie's looking at the bottom line, and Mike isn't, because Mike is an engineer.
Yeah.
Right? Mike wants to build the best possible product, and Charlie wants to make the most possible money. And that was the conflict. And Mike came out of that bruised, I think. Yeah. But in fact, we did transform the organization, and then we had this problem. We didn't want to be the PC group that made token efforts towards openness and commodityness, and then sabotage themselves by putting in a couple of proprietary things, right? We wanted to embrace it, but we also realized that we were not ever going to be the lowest cost manufacturer. The company's structure, their tax structure around manufacturing and all the other stuff, would make it very, very hard, at least on paper, for us to ever be a cost leader. So we had to add value. And that's where the StorageWorks stuff came from. Right. How do we add value to standard, when the interfaces on both sides of a storage controller, the interfaces that talk to the disks and the interfaces that talk to the hosts, are standard. So one way is, well, SCSI's this loosey-goosey standard, we get to start to participate in the standards process, right? So we did, and in fact, it was my organization, because at that time I was the storage architect, so I got to send people out to various committees. The disk people also did. At this point, my storage architect title was really the controller part, because I couldn't contribute to a real technical discussion around magnetic recording on either disks or tapes. But I could, be the point person to send people to standards committees and stuff like that. And then we also started to figure out where we could innovate. And what came out of it was the two places that we could innovate was controller performance and features and packaging. And later, we could innovate in terms of enhancing the standard, right? And making that enhanced standard available to the world and counting on our time to market advantage. So the original StorageWorks concept, if I was going to lay it on three people, the three people I would pick would be Bob Passmore, who was a marketing guy, who came up with the idea that, look, why don't we build something that was a modular packaging system based on SCSI drives, where drives would slide in and out, because at that time that was not an industry standard feature the way it is today. You put the drives in a canister to solve the FCC problems, of radiation, and to protect the drives when you pull them out.
And they're hot swappable.
And they were hot swappable, exactly, which was not something that SCSI was very good at. Mark Lewis, who handled kind of the electronics side and heat, I think, side of the StorageWorks products, and Ruben Martinez, who handled the physical packaging and vibration issues and all that stuff, part of the packaging, right? And those three people, Bob was an ideas guy and a marketing guy. Ruben and Mark were the implementers, and between them, they first came up with the concept of the StorageWorks brick and the various size packages that it would fit into, and then Mark and Ruben went off and implemented it, and Bob started crafting a marketing strategy around it, right? And
that would have been right about 1989.
Yeah, into
Like
1990 and even 91, because it took us, a while to turn the battleship, right? And we still had to fight a real, just like anything, when you change your strategy like this, you send a bunch of guys in on the new front to fight that battle, but you have to allocate a bunch of people to fight the rear guard action, to make sure that you don't have a gap between the old products and the new products, and your revenue falls to zero and you go bankrupt before the new stuff gets out. So there were always a set of people who were enhancing the existing products, and that's where some of the ESE, the solid state disk follow-ons came out, the HSC 90 came out. It's like, what can we do to juice these products, keep them attractive in the marketplace, at least hang on to our base, while we develop this stuff, which would satisfy our base and also potentially allow us to become an independent storage supplier, a captive independent storage vendor, right? So we did that, and I kind of bounced back and forth between the two camps because of where I was, and I was intensely familiar with the existing products and could come up with, hey, we could do this, and it's a small amount of effort and a potentially large amount of hay we can make out of it in the market, because there's a good benefit to it, things like that. And also started working on the new controllers, of which the first controller I think was called the HSZ40, right? And it was built out of standard parts, because we didn't have time to do any custom VLSI. So it was basically a processor and some memory and some SCSI interfaces on the back, which were 8-bit single-ended SCSI, and a bunch of interfaces on the front, which were 16-bit differential SCSI, so that you could put it a long way from the host system. And we took some of the HSC software and ported it, but mostly we wrote the software from scratch for this because everything was different, and we had to write all these SCSI drivers, and SCSI was horrible. And we had to learn the hard way, and the drive guys had to learn the hard way. And it wasn't enough that our controller had to talk to our drives. We could kind of enforce the fact that our controller only had to talk to our drives. We didn't support random third-party drives in back of our controllers, but our drives had to talk to everybody.
Yeah. So essentially you had to qualify certain brands
Yes.
would run on
Right.
your system.
Right, and we would always test ourselves with other people's drives because having a single source is a terrible idea, even if it's yourself, right? And there were certain places that if they caught fire, we would be in deep trouble if we couldn't get drives from somebody else. So we never, I believe, shipped our controllers with other people's drives, except in certain situations where they maybe had a product that we couldn't get anywhere else. But we tested our controllers with
Right.
other people's drives.
Just for full disclosure, this time frame is when I left DEC, which was May of 91 rather.
Right.
And Grant left DEC the next year, as did Mike Riggle.
Yep.
Grant ended up going to Adaptec, and Riggle ended up working for me at Maxwork.
Right.
Right, but that transition
Right, and
between
some
the
of-
three
and
of us all happened right in that time frame.
Yup.
That you're beginning to start shipping StorageWorks.
Right. And part of it was, and I think, I can't speak for Mike Riggle, but Mike looked at this and went, where's the engineering input to this? Where's the drive to excellence? Where's the,
Well, I think he
huh?
was worn out by that time.
Yeah, and also, as I said, Charlie had worn him down.
Oh, yeah, right.
Yeah.
Yeah, and he
Right.
was definitely worn out by Charlie. And, actually, Riggle never worked full-time for Max early, so as a consultant, but he did until he died.
Mm-hmm.
Died in 2003, I think it was.
Yep.
But anyway, bottom line is there was a transition there, and Bob Rennick now became the storage guy
Yes.
in that time frame for StorageWorks.
Yep.
Right?
Yep. And Bob had a experience with actually a wide variety of things. He actually came from
Well, he
the
ran
special
HSC
system.
group for a while.
Yeah, he came from the special systems group in California, in Fullerton, I think, and wound up doing a
Right.
very creditable job of managing the storage group until he ran into a political war, which I get into. The HSZ40 was to get us into the market, and we had a plan to build a follow-on controller, which was a lot higher performance and did a lot of nice things. And unfortunately, but fortunately for us, right around this time, and I'd have to look it up to make sure I've got my time frames right, Seymour Cray, who had moved to Colorado Springs to separate out, I think it was Cray Research from Cray Computer,
Yeah, he
or
created a
vice
new
versa,
company, yeah.
right?
Cray
And because of some political machinations back there, where Cray Computer decided to go a different way, and he, Seymour Cray was a Mike Riggle type and wanted to just pursue some engineering, the leading edge of engineering,
Right.
and hired some really good ASIC designers to help him do that. He wound up getting killed by some idiot on I-25.
Well, he died in a car crash. I thought it was a solo accident, though.
Huh?
He actually hit
No,
the-
it was some guy who did an illegal merge onto the highway, and
Oh, wow.
yeah, right.
But I know he went off the road. and
he went off
died.
the road and got killed.
Right.
And which was horrible for the computer industry as a whole, but we picked up a couple of VLSI guys, a couple of ASIC designers. And so we started them on the project of doing some big chips that would be the heart of our next generation controller. And it was also around this time that Ellen, who had transitioned from the advanced database stuff, but then Digital at some point sold off its database assets, and she actually left the company.
Right.
Around this time, this was around 93 or so, came back to Digital as the head of the storage controller group. So
Right. We're actually going to discuss that detail with her.
working with my
Right.
wife again.
Right.
Right. We got the HSZ40 out. We had a plan for the
The HSC.
HSZ.
Z,
Z
yeah.
for SCSI.
It's hard to keep track.
SCSI, right?
Oh, is that what the Z was for? Was for SCSI?
Yeah, we need we need a letter. You know, digital had this naming architecture. So, I mean, it got worse because when Fiber Channel came along, we couldn't use F because of the DSSI, so we used G for glass. This was the HSG series. The HSZ 80, which actually the HSZ 70, which was going to be the next controller, ran into trouble, technical trouble, and the hardware manager of that product hid it from Ellen, right, until it was too late to do something about it, and we were faced with a 1-year slip on this product that was going to replace this, you know, this thing that was barely adequate that we did just to get into the SCSI business. And so we had to come up with a stopgap product, and we just renamed the stopgap product, which is a juiced up HSZ 40. We renamed that as the HSZ 70, and the new products became the HSZ 80. And because at that point we could see Fiber Channel coming, we planned on a Fiber Channel version of it. And around that time, we started, there was a guy in Shrewsbury, and I'm hoping I get his name right, it was Bill Ham, right, who was a signal integrity wizard. You know, a guy who really understood how to keep a signal going for a long distance and not degrade it. And he started looking at how we might be able to juice the SCSI bus itself, and came up with two things, one of which was a way to double the speed of the differential SCSI bus that we use to connect the controller to the hosts, and the other was a way to stick a device. SCSI timing was so loose, the length of the length of the SCSI cable was determined by kind of signal integrity issues, not delay time.
And that was relatively short. I remember, like 20 feet?
It was 20 feet or 20 meters. Yeah, 20 meters, I think,
Right.
for differential. You know, like 5 feet for single-ended SCSI, and you had to be in the same cabinet because of the ground loop problems. So he did two things. One is he came up with a way to double the speed of the SCSI bus, and two, he came up with a way to build a SCSI repeater, which was a box that you could stick in between. You have a differential SCSI coming into it that goes to the host, and another differential SCSI that came out of it, which got us to double the length of the bus. Okay, I don't think you could put more than one in there. Again, then you did hit timing issues. They were loose, but not that loose. And so we decided as a marketing ploy to take these two improvements to the standard, which we went to the committee and got blessed, and market it as Ultra SCSI.
All right.
Okay.
Did it become then a standard?
And it became part of the SCSI standard, and we got to have our cake and eat it too. We were building a standard product that had advantages over everybody else's commodity standard product, and that actually was pretty successful until Fiber Channel came in and became the bus of choice eventually, you know, over years, for hooking controllers to hosts over a distance. Right, so Ultra SCSI turned into a good gap filler, and helped us hang on to the market, even though the HSZ 80 was late, because when it came out, it was going to be twice the speed of every other controller.
Talk a little bit about the difference between SCSI and Fiber Channel in terms of their data integrity and the way they worked, and why Fiber Channel actually won that battle, even though it was more expensive.
Right. Well, so first, Fiber Channel, of course, is just another vehicle for transmitting the SCSI protocol with all of its warts. Right. The SCSI protocol was designed for places where wires, you know, where you wiggle wires to do things. But just like we did with the SDI, when we changed it from a parallel bus to a serial bus, there were tricks you could play to hide that in Fiber Channel. Fiber Channel was a network designed by people who didn't understand networks really well. Okay,
But they understood channels.
But they understood channels exactly.
Define the difference between a network and a channel.
that's difficult. Channels tend to be asymmetric. Okay, there's networks tend to be completely symmetric. Anybody can talk to anybody else on an equal basis. And networks are designed for an environment where packets can be dropped, delays can be arbitrary, packets can pass other packets in
Basically,
progress.
best effort.
Right. Well, best effort, and then you put everything together at a higher level
Right.
of the protocol stack. And Fiber Channel was designed for reliable communication, even though it cost quite a bit in terms of some end-to-end latency issues. And when they finally got to switches, the switches had to do all kinds of magic to preserve the illusion of reliability. And in fact, what would happen in Fiber Channel was that when a packet, in network stuff, when a packet gets dropped, it's just par for the course, right? In Fiber Channel, when a packet gets dropped, it usually causes a 5 to 10 second hiccup in the system because it wasn't designed according to the same kind of principles that a network was designed at. It's a serious thing. It would break the connection. The connection would have to be reformed, all that. But it was fast enough, and especially if you used fiber optics to transmit it, it was way long enough. It could go, kilometers, and it was the next big thing, right? And so we wound up, pushing to not be on the trailing edge there.
And then it becoming very reliable, right?
Huh?
It
Did.
became
It became a perfectly good bus, and in fact, it was interesting because as part of the political wars we wound up fighting at the time, and I'll talk about those, we had to talk to the people at Digital who didn't understand why the hell we were using this weird storage bus instead of Ethernet, right? That storage should be on Ethernet, and it's now 2018, and some storage is on Ethernet, but an awful lot of it's still on Fiber Channel,
right?
right? And so the Fiber Channels had a 20-year run at this point, and 4 doublings of speed, right? I think going from one gigabit per second to 16, huh? And no, Ethernet passed it, but
You're right.
but because the storage protocols that run over Ethernet aren't as efficient as the ones that run over Fiber Channel, lots of new installations in Fiber Channel. So luckily, we were right because there were pitched battles, and it was part of a much larger issue, which I should talk about, which was now that we had these products that could talk to anybody, we wanted to sell them to anybody. Right? So in fact, Mark Lewis, who was one of the StorageWorks engineers, turned himself into the OEM product manager for storage and started going out and finding people who we could rebrand our storage canisters and the shelves that they went into and stuff. And we also started advertising storage for sale in magazines. Right? We bought some Sun systems and some HP systems and some IBM systems and made sure, because with SCSI you could never be sure it would work until you went in and tweaked all your software parameters to match what the host did, so that we'd have profiles for Sun or HP or IBM, and we started selling storage to the world, which caused the rest of Digital to wonder where our allegiance lay. That why weren't we concentrating on making them better, because they were now facing the same crisis. We were early in Digital in facing the proprietary versus open crisis, okay, compared to the rest of Digital. They were now really going through the crunch part in the early to mid 90s of competing with open systems, and they were looking at it and saying, you're making the problem worse, not better.
The real irony of this point here is that Digital was probably the most proprietary of all systems out there. Nobody was more proprietary than we were. Everything was. actually became a leader in the open faster than just about anybody else.
for storage.
Right.
And
IBM tried it, never got there.
right,
They
and
could not pull it off.
and we were all of a sudden also making money.
Right.
Right? Again, I mean, I don't think we ever lost money, but we were seeing sales flatten and profits drop.
You're becoming a leading.
Right? And then with the StorageWorks stuff and being able to sell, through distributors, right? We saw sales start to rise and profits going up, and we were a growing business, and the rest of digital looked at it and said, you guys are giving our competitors ammunition against us because storage is now not an advantage for us. Plus you're using engineering resources that you could be using to make our stuff better on doing all the qualifications and da-da-da-da-da. And yes, they had a point, but it was yesterday's point. Huh? Yeah, right? But that triggered a bunch of wars between storage and the rest of digital, right? And specifically what it triggered was some of the systems groups at digital who were looking at their profit, which at this point was negative, and looking at what would happen if we added the positive profit of storage to the negative, to the losses of their organization, started campaigning that storage should become part of the server group.
Right.
Okay?
Right.
Ellen can go into that in more detail. She was closer to it, but the upshot is it ultimately led to a decision at the top levels of the company that should happen, which led to the departure of Bob Rennick because he knew that he would have no job because he fought like hell to keep storage independent and made a bunch of enemies in the rest of the company. So a woman named Laura Woodburn, who came over from the VMS group, became the head of storage and managed the transition to ownership by the system group and got burned out by it and left. And at that point, Ellen can tell you, they reached down and picked Ellen to be the next vice president of storage,
Right.
which she'll give you the story, but I can tell you that it put me in an interesting position because by then, and we'll backtrack and talk about this, I was the CTO for storage.
Right. So you essentially should have reported her.
And so technically, right, as CTO of storage, I reported to the vice president of storage, but digital was a pretty liberal organization about couples. Two couples could work in the same organization, but one of them could not work for the other.
Right.
One of them could not have salary control and evaluation control over the other. So I had to leave storage. Okay, and that worried me. So I called up Bill Strecker, who by then was the CTO for the entire company, and of course I knew him because of work on the VAX architecture.
Right.
And he said, come work for me. So I said, okay, and I left storage and I became a member of the office of the CTO for digital. And my first day I show up and he says, I want you to work on storage. And so I went back to my old office and my old phone number and my old job, right? Only I was now not working for my wife anymore. And that worked out really well. I mean, I had a history going way back to after the VAX came out of being not just an engineer, but I'd be an evangelist. I'd go out and when the VAX first came out, I'd go out to some of the scientific customers that we had all around the world and give them detailed presentations on the VAX, how it worked internally, because these guys are all, our technical customers, people like CERN, ate that stuff up. They loved it. They wanted to know what they were getting and how it worked, and I was good at giving those kind of presentations. And then in storage, I would always spend part of my time talking to customers, talking at customers sometimes, and actually talking with customers sometimes and listening to what they said, which is important. And then, so when Ellen became the head of storage, we would actually go out together.
Yeah, you had a little period there where you could not even travel together.
And well, that was under Compact.
Right.
That was under Compact. Digital was cool about that because I didn't work for her, right? And so we would do our little song and dance. In fact, the line that I would always use to like loosen up the room was Ellen would introduce herself. She's the VP of storage. I would introduce myself. I'm the CTO for storage, and we're married. And I'd say, well, one of us slept our way to the top, but we're not sure which one. So and that would loosen people. And we had some shticks that we did, and it was actually a really good time in a way, because we didn't mind spending all that time together, professional roles and personal roles. And it was a bad time in the sense of we had to be very careful about managing our personal time, to not become all-consuming and ignore the kids and work ourselves to death and stuff like that. So we would schedule hard, vacations, right? And say, no, sorry, we're not here. You're going to be without the CEO and the CTO of the business for these 2 weeks and stuff like that. But overall, it was a great thing to do, to be what somebody talked to as the mom and pop shop of storage, right? They actually meant it as a denigration, but we took it as a compliment.
So what was the time frame that Ellen became vice president?
She became vice president, and I'll probably get my stuff wrong, and she'll get it right. My memory was it was around November of '96.
That would make a lot of sense, right?
Okay, that the transition to us being part of the systems group happened around the end of '95. Actually, it would have been it would have happened on a fiscal year boundary.
Okay.
Right, Digital's fiscal year ended in the end of June, so Laura Laura Woodburn started as the VP of Storage probably in the spring when Bob abdicated because he had to.
Okay.
And took it through October or so, and then Harry Copperman, who was the head of the systems group at Digital, did kind of a job search. A bunch of candidates, surfaced. I don't want to steal all his thunder on this, and ultimately he picked her. So November of '96, and she had about a 15 or 16 month tenure until January of '98. When we announced that we were merging with Compaq. Right? And the actual merger, again, occurred on the fiscal year boundary at the end of June that year. So she really had about a year and 2/3, year and 3/4, and did very well in the job, and she'll tell you all about that.
Oh, yeah. Now, in the meantime, by the way, just to go back, between that time frame I talked about a little earlier when I left in May of '91, and 95, 96, when this was happening with the storage group taking over and Ellen becoming vice president, Charlie had sold off most of the vertical integration part of the business, especially the disk drives,
right,
and the thin film heads and the plated discs and the tape, which turned out to become
the winner.
The winner, yeah.
Yep.
For Quantum, all
Right.
the Quantum.
Right.
And that would have been like 94, 95.
That would have been about '94, and that was when I became the CTO for storage,
Right.
because until then, there was kind of a three-headed CTO group in storage.
Okay.
I was the controller guy, and there was somebody for disks and somebody for tapes. And to be honest, I can picture the tape guy. I can't remember his name. I can find it, and I'm trying to remember who was after Mike Riggle left.
Riggle left in '92.
Right. So after that, I'm not sure who was the CTO for discs. It could have been Mike Lease or Norm Field, or no. It was probably Mike Lease.
We go fill that in. But bottom line, there was a huge transition. We'd gone from a totally vertical integrated organization in '80s
to one that was internally
selling off most of that chunk by the middle '90s while it's now gone.
Right.
To becoming now
And in fact, you could see Charlie's hand in that all the work that he had done in making all our interfaces standard was to give him the option, if we could not get our manufacturing costs down, which was, I think, ultimately the issue, right, is we weren't vicious enough. The disk drive industry was an industry in which you could earn your salary by cutting a nickel off the cost of a drive.
Oh, absolutely.
Because at the volumes that drives were being produced, that nickel would pay your salary.
The volumes that we generated at DEC were never anywhere near what they turned out to be later in the commodity world. We were doing 100,000 units a year, and the commodity worlds were all doing several million units a year.
Right.
Big difference.
In fact, one of the things that we were proud of in StorageWorks is, at one of the big company kind of get-togethers, technical get-togethers, somebody said, one of the problems in this company is we've never shipped 1 million of anything.
Right.
Which was probably true. We
Sure
we
it is.
weren't that far off with some of our terminals, like the VT100 and stuff like that, but we didn't. And sometime while Ellen was VP, we shipped our 1,000,000th StorageWorks canister.
So you did actually get.
So we actually, even though it was a box, a plastic box that held a disk drive, right? We shipped 1 million of them. But ultimately, disks are more complicated than plastic boxes, and we just could not get the formula right. And Charlie sold off the disk. He wanted to sell the disk business, and Quantum wouldn't take it without the tape business,
Right.
and they were
Well,
smart.
and they actually wanted thin film heads. It turns out they didn't use that very long, but they wanted the heads.
Right.
Because we were vertically integrated.
Right. They continued, I think, some of our products. Okay. But and then I think when Maxtor even took stuff over from Quantum, they continued with some of our products. But I think within 3 years, it was pretty much gone. The engineering group in Shrewsbury was either working on Quantum products or later Maxtor products, or they were gone, to other companies and stuff. So at that point, all we were was a controller and some software organization, and that's when I kind of assumed the title of CTO, because there wasn't anybody else, right?
So let's try to finish off the digital storage.
Yep.
Digital story here in the next 30 minutes or so, because I want to get into the post-digital story.
Yeah, sure.
So what happened next? So you're now up to the point where you and Ellen are basically in different organizations. She's
Working together. Right.
And what happened next? And then, of course, getting into the compact buying, or merger.
Right. So, and Ellen can give you the details, but basically, at some point, Ellen went to Harry Copperman, and said,
Harry had the system group that owned
Harry
storage.
had everything, the system group that owned storage,
So
and
she
the guy
worked
who
for him.
owned the VAX processors was a guy named Jesse Lipcon,
Right.
who was an incredible engineer. He was the reason why digital was part of the Ethernet consortium way back when, because the other two companies, Sun and Xerox, I guess, that were in the Ethernet consortium, came to digital and said, we've got this great concept, it's a network, and we can't make the transceiver work. We need Jesse Lipcon. And digital said, you can have Jesse Lipcon, but we're part of the consortium. Right? So, that gives you an idea of the kind of analog engineer Jesse
Of
was.
course, the guy that made the Microvax
Right.
product.
And then he
ran that for a long time.
worked his way up into management, and he was pretty good at the management side of it
Absolutely.
too. He charm school stuck with him. And in fact, Jesse was one of the people who recommended Ellen for her job. Again, not to steal the thunder. And Ellen eventually went to Harry Copperman and said, here's our numbers. It doesn't make sense for us to be part of the system organization. Here's the outside opportunities we have, da-da-da-da-da. And Jesse, of course, was opposed to that, because he wanted storage to help him build his system business better, and the profits were good too. Harry eventually decided to spin storage back out as an independent organization in digital, and so Ellen was now the VP of a top level kind of organization, reporting to Harry, not reporting to Jesse. And
when was that, approximately?
let's see, Ellen came in late '96, and I guess Ellen will tell you, but I guess it's probably around the turn of the next fiscal year, around June
Before Quantum.
June of '97.
Okay.
Huh? And Ellen will go into the details, but basically when Ellen came in, the business was a $1.2 billion business. And when Compaq took us over, the business was a $1.8 billion business. And we were growing, we were profitable, we were giving bonuses to our employees, because that's Ellen's way. And the rest of digital was losing money and looking for a buyer, and so it was a very different atmosphere. You know, storage was a good place to be in digital.
Well, and I think it's pretty well known that besides the service business, that Compaq wanted the storage.
The storage
what
business.
they wanted.
Yep.
They also got the can't remember the name of the processor, the high-speed processor, but I don't think they really ever did much.
Oh, you mean Alpha?
The Alpha.
Alpha. Yeah, I was, because of my history on the VAX, I told you that the VAX organization was kind of the inner circle, and then there were 2 circles out. So I was in one of the intermediate circles on Alpha. You know, I was a storage guy, but I would get to review the architecture, right? And in fact, Alpha was late, and it was partly because of some digital dysfunction. It turns out that one of the California labs had built a RISC processor that was pretty nice, but couldn't get the internal buy-in to make it the company's flagship. Dave Cutler out in Seattle actually built a RISC processor.
In fact, he did several.
He did one. Its code name was Frigate, as in the ship, but also frigate. And finally, the company got their act together around Alpha and realized that if we didn't cannibalize ourselves with a RISC processor, somebody else would, which is the classic digital issue. And it was a great processor, and it was late to market, and ultimately made a splash among the processor, cognoscenti, but didn't make a market splash. It was part of our decline.
And the Compaq purchase was storage.
Yes, we were one of the high spots. We were making money, and we were building the kind of storage products that Compaq could use because they were all open. Right. It was a difficult transition for us. Okay, because there was a total mindset disconnect between Compaq and digital on a lot of levels.
There was a huge culture change.
Well, there was a culture change. Compaq was very Texan, very male, very white. Digital was a pretty diverse organization, especially in storage. But more from a technical point of view, Compaq would throw the word enterprise around, but being a PC company, their idea of enterprise was very, very different than our idea of enterprise. And so, there was some tension. We also had now 3 centers of engineering. We had Colorado, Shrewsbury, and Houston, and products had, and they're obviously one of the synergies you get from a large company is to start sharing pieces, and there were the usual fights about that. And a consensus approach to engineering doesn't work when there are 2 cultures involved, right? To have a consensus culture, everybody has to be part of the consensus culture. So we had to learn a new way of negotiating technical stuff, and they had to learn a new way of doing it. And it was much less fun. And in fact, my response to that, again, this is something I'm not super proud of, but was to step away a little bit from fighting these ridiculous technical, political battles and become more of an evangelist. Take the, part of a CTO's role is always evangelism, right? I kind of amped that up and worked to shepherd some of the existing digital products and the next generation digital architecture, because we were in the process of introducing a new storage architecture, the first really new storage architecture since StorageWorks, right? And it was based on StorageWorks, but it was a controller architecture for virtual storage. Okay, for what in the industry was starting to be known as virtual storage. And for us, what that meant was that instead of talking about individual disk drives or RAID sets of individual disk drives, the binding between the storage devices that the user application sees and the actual storage devices was fluid. It was mediated by a set of tables that kind of looked like the page tables in a CPU virtual memory architecture. And by adding that level of mapping and indirection, you could implement things like snapshots, like what you call late binding meaning you didn't have to take your storage and say, okay, this much of it is going to be RAID 1, this much of it is going to be RAID 5, this much of it is going to be RAID 0. You just said, this is storage, and if you want RAID 1, fine, we'll find 2 pieces of it and mirror them together dynamically, and there's your RAID 1, and if you want RAID 5, we'll find 5 different pieces of it on 5 different devices, or however many, and marry them together in a parity relationship, and give you, if you want to grow a device, no problem, we'll find more storage and add it on. So it's something that's commonplace now. There's no other way to do it. But we produced some architecture documents and then backed it up, and went out and marketed it, right, and backed it up with some actual controllers. And I'm spacing on some of the names. The name of the architecture will come to me, the name of our first controller. But in fact, I think this was around, we started this in 96 or 97, and HP stopped selling the controller that we built about 3 or 4 years ago. So it was a good long-term architecture and had some good long-term products, and it survived two company takeovers.
It was actually a huge transition in the industry, and you can give a lot more detail on this, but virtual memory had been around for a long time.
Right.
Virtual storage didn't exist, but people were talking about it for years.
Yes.
And you guys were one of the first guys to put together
we
a
were
comprehensive way to do it.
Right. We had an architecture. I remember John Toigo, who was a industry pundit, would continually, and we didn't even pay him to do it, would said he read our white paper on it, and it was the most impressive thing he had seen in storage, and he was a big backer of ours, because he could see the benefit of it. Storage was now, disk drives were fixed size and fixed performance, but storage didn't have to be. Right. That was a nice way to kind of go out as digital to introduce that, right? And Compaq recognized the value of it and kept it going. Okay. To their credit, right? But it was much less satisfying being the CTO of the Compaq storage group, which I was, than it was being the CTO of the digital group. The culture was very different. There was a lot more travel involved because it was split 3 ways. There were the kind of fights that I don't enjoy, as opposed to the kind of fights that I do enjoy, which are based on which is actually better. So Ellen, who, because she was a VP at the time of the acquisition, merger, if you want to use the market speak, but it was an acquisition.
Yeah, Compaq really acquired that.
Stayed a year. She did not get the VP of storage job at Compaq. That went to a guy named Howard Elias, who used to run the PC group at Digital, and therefore was much better mesh for the Compaq culture. She pulled the ripcord on her golden parachute 1 year after the merger, and I stayed on for about another 9 months after that. Okay, and then I didn't have a parachute. I just jumped.
And then just for full disclosure, at that point, we're now talking year 2000. The 3 of us all ended up working together in the same consulting group.
Exactly.
Infusion.
Exactly, right. And yep.
And did that for about 3-4 years.
We did it. We for even more than
you
that.
You had your own group you called Tutelary for the tool.
Well, and that was yeah, right. Tutelary is a nice word because it means guardian, and it has a Lary in it, and there's 2 of us, but we did that because you didn't really want to be an individual member of Infusion for liability issues. Right. Infusion was a partnership of corporations. Yeah.
Okay, we're going to just wrap up real quickly on anything else you want to talk about DEC before we transition to post-DEC.
No, we will. Well, it'll come back as rat holes probably.
All right. So I already mentioned that the 3 of us ended up working for a consulting company. It was kind of a loosely knit network of independent consultants at that point called Infusion.
Yep.
It was founded by Michael Peterson, and Phil Black was part of that. And so were several other people, but you, Ellen, and I did several things together. Also brought Bruce Thompson, and I did a lot of things with Bruce.
Right.
But talk about Infusion a little bit from your perspective,
right. So
and what that's all about.
What I saw was that the rotating technical industry finger of what's hot.
Of
Okay, of what's hot, what technologies are hot.
Oh, okay.
Around 1999 or 2000, started to point at storage. Okay, and there was a tremendous ferment of storage startups, and part of this was the fact that, and we didn't get into this because it's independent. You know, there was this huge explosion in disk capacity through the 80s and 90s. I mean, you know, it's an insane
Based
story.
on MR heads.
Well, there was always some technology that was going to goose. Right, we're starting to run out of them, but you know the fact that you know in the late '80s we built a 1 gigabyte drive that was a 9-inch drive, the RA90, and now a gigabyte costs a nickel, and an RA90 costs probably $20,000. Right, the ratios are just unbelievable. So, and what drove that largely was thin film heads and thin film media. Once they got the kinks worked out, what I remember is there was, you know, there were the product introductions every year, and every year was 50% or double. And then right around when the 9 gig drive came out, there was like a 2-year hiatus because of, you know, little bugs in the technology that needed to be worked out. So storage capacity had finally gotten large enough that there were issues of, again, performance, the ratio of size to the amount of number of IOs you could do, and also given the people had all this storage, they needed to manage it, and they were looking for anything that could help them manage the storage, from software to features in the storage controllers like snapshots, to moving to NAS from a block-oriented device to NAS to move their file management off into another system, to you name it. And that caused a tremendous amount of startup ferment in the storage industry. And Michael Peterson, to his credit, recognized that early on, and recognized that there was money to be made providing advice and networking in the marketing sense to these startups, which were generally formed by people who had a bright idea but didn't understand how to surround their bright idea with all of the state of the art that they needed in storage to take their diamond and get it out of the mud that it was buried in and put it in a proper setting so that it would sell.
Yeah, and even worse yet, most of them didn't know very much about business.
And they didn't know about business, they didn't know about storage, they didn't know about the storage ecology, you know, who's doing what to who. And so he realized there was a lot of money to be made, and he started a series of conferences called, I think there were the Server Storage Conference and some other things.
For actually a number of years before that. He'd been in the conference business for about 10 years before he even founded Infusion.
Right, and the interesting thing about these conferences was that there was a public track of people giving presentations.
Yes.
But all the action was basically the equivalent of speed dating between companies and other companies, companies and VCs, companies and the distribution chain, et cetera, that would go on the side in these conferences, which he would enable. I think there were sign-up sheets, and you know, as I said, speed dating is not a bad a metaphor for it. So I went to some of those conferences when I was at Compaq, in fact, through the machinations of a Compaq kind of techno marketing guy named Roger Reich. I wound up getting a Lifetime Achievement Award at one of the storage.
Well, of course, Roger was the guy that worked for us at DEC, right?
Right. Roger was a product manager at Digital, wound up at Veritas, putting together a fairly successful consortium around some storage stuff. He's a good techno-politician. He's out of the business now. He raises marijuana. But Michael effectively recruited me, to this infusion group, because he said that one of the results of these conferences was that he was besieged with phone calls from companies looking for advice, right? And this sounded like a really good opportunity because one of the things I'm good at is I'm a quick study. I can absorb large amounts of information. And so I got into a mode where, after I left Compaq, where I became an industry consultant, where a large amount of what I was doing was one-day engagements with startup companies, sometimes alone, sometimes in the company of a business person or a marketing person, sometimes in the company of you, right? Where the morning was spent with the startup company giving us their standard slide pitch and then diving down deep into the technology under it and their internal plans for how they were going to develop it. And then in the afternoon, the tables would turn and we would regurgitate back to them what we heard and what we thought was worthwhile and what we thought needed a lot of work and what we thought was doomed. And also, because in doing this, you get a huge amount of information about the storage industry as a whole, hinting to them without just leaking anybody else's proprietary information that there were people that they should open a conversation with, the networking part of the job. And I enjoyed the hell out of that. First of all, it was very remunerative. The money was good. And second, it meant I could kind of go in, stock up on coffee, and try to be at like peak performance for 7 or 8 hours, and then I would just collapse, because between the information inflow and the information outflow, I was just a rag afterwards. And of course, they'd want to go to dinner, but it was a lot of fun, and I learned as much as that's the good thing about a consulting role is you learn as much as you give out, and the learning makes you more valuable in your next role.
Right.
And so I did a bunch of those, and a couple of longer engagements, some through Infusion and some independently. I had a fairly long engagement with Dot Hill, the fusion of Box Hill and a company that probably starts with the word data, but I don't remember. They needed to implement high-level functions in their storage box, which is a very high performance. They had some really good software guys and one particularly brilliant hardware guy. So their hardware was great and their software didn't get in the way of the hardware, but they were absolutely base functionality, and they got absolutely base dollars for their absolutely base functionality, and they wanted to move upstream. And so I spent some real consulting time with them going, okay, here's how you would design a snapshot system, or here's how you'd virtualize your storage, and here's how you do asynchronous replication over distance and synchronous replication over distance, and all that kind of stuff. So I had a couple of those kind of more extended technical things, like a 3-day design review on some company's new controller or something like that. But an awful lot of it were drive-bys, okay? One day things, and sometimes I'd get paid in money, and sometimes I'd get paid in stock or with a position on an advisory board or something, which came with stock, and so and it turned out that I wound up pretty well. I wound up I kept a record of the companies whose advisory boards I was on. And the standard kind of rule of thumb is 1 out of 10 startups succeed. I was batting 375 at the end of the day.
Well, you had some winners.
After all of them left, I had something like 16 companies that I was on their advisory boards, and 6 of them had significantly successful exits. So
talk about a couple of those,
because
I can't remember the names, but you will probably recall most of them.
So the
best one that did Scuzzy out of New Hampshire was one of the ones you worked for a long time.
They were an incredible company. The company was called Equalogic.
Right.
And this was not an Infusion engagement. This was one where the 3 major players, the CEO, the VP of engineering, and the CTO were all ex-digital from either the Unix group or the Networks group. Peter Hayden was the CEO, and Paula Long was the VP of engineering, and I had his name a second ago, was the CTO was from the networks group, and his name will come to me. They literally called us up and said, we just started a company. We just got angel funding. Right. We want to talk to you about what we should build. We have an idea. And so Ellen and I were both invited, and we went to them. And they had a 9-page, they had done their homework. These were super focused people, especially Paula, best engineering VP I've met, and that includes a lot of people.
She's been very successful since too.
Yeah. So so driven that at one point later in our engagement, she engaged Ellen as a mentor, not for any technical reasons, but to teach her how to relax.
Oh, is that right? That's interesting.
And not be completely obsessed by work. Right? But they called us in, and they hadn't really opened their doors yet, and we sat down and they handed us a 9-page checklist of the major features of every storage system that they had found out there by doing their homework. And we went down that checklist, and it was like, you got to do this, you got to do this, you can do this, but you can do it half-assed. And this, and this you can slough. Wait for a later version and stuff like that. And we basically defined their product strategy for them of what they were going to build. And then they took that document with the check marks and the various things and turned it into a beta within 15 months. The most impressive, feat of startup engineering I've seen.
Well, it absolutely was. In fact, the one thing I do remember specifically on them, because I also talked to Peter early on about it, was they were going to write a complete from scratch RAID system, and nobody had ever done that in less than 2-3 years and made it commercial. And
right.
They put a date on it, and they pulled it off, and you were blown away by that.
I was blown away by their
Absolutely
execution.
blown away by it.
And they did it in spite of actually changing streams. We had recommended to them that they not use SATA drives because SATA drives had all kinds of problems. They'd go away. Right, SATA was the new SCSI. It was cheap and easy, but had all kinds of problems. We recommended that they use whatever was one-step fiber channel arbitrated loop or something like that. But the drives on that were much more expensive, and their VCs looked at it and said, no, we want you at a different price point, use SATA drives, and they actually switched to SATA drives, and we understood why. We didn't fight that decision, but that derailed them. Who knows? They might have gotten in a year if they hadn't made the switch. They're just fabulously productive.
And of course, the bottom line of that was they were going to go public, and they got bought for $1.4 billion, as I recall, by Dell.
Right. They got bought by Darren Thomas at Dell, who was one of the Compaq people, who we had kind of cultural conflicts with when Compaq took over Digital, and it was very satisfying to receive a rather large 6-digit check with Darren Thomas's signature on it afterwards.
So was that your biggest win, or did you have another one close to?
There were two wins of that size, right? The other was an interesting one, and you know it. There was a company named Z-Force,
right,
which was a scalable NAS company,
right,
and it was founded by a bunch of crazy Bulgarians, right, who were also just sharp as hell.
Yes, they were.
Right,
right.
and Z-Force ultimately failed, but not because of a lack of good ideas, and they reformed a little bit later as a company called 3 Tera, right? And the 3 Tera was, I forget, a trillion instructions per second, and a trillion bytes of storage, and a trillion bits of network bandwidth or something. It was an aggregator. The idea was to build an effectively super VAX cluster type architecture where they had figured out a trick for kind of distributed caching, where they would actually be able to run parallel applications on this super cluster. And interestingly enough, we had done some work on this at Digital, and our work at Digital had shown that it wouldn't work. And so they liked the advice I gave them in Z-Force, the fact that they were not one of my 375 win percentage, they said, we want you to be in on this, even, and I said, it's not my area of expertise, it's like networking and applications and the Microsoft apartment model for threading and all this other stuff. They said, that's okay, you're bright, we want you on board. And my main contribution to them was to tell them that it wouldn't work. And based on that advice, they didn't take my advice, but they said, let's do a proof of concept before we put all this effort into actually building the product. And the proof of concept didn't work. Okay, it worked, but it scaled, it scaled linearly up to 3 or 4 processors, and then at 8 processors, it was barely above 4, and it just stayed flat no matter what. And so they said, yeah, you're right. They said, but we have this management architecture that we built to manage all this stuff, and people are now building clouds. And this management architecture is an application deployment architecture for clouds, where you just use a graphical language to say, I'm going to hook this app to this app, and they're going to communicate with this protocol, and they're going to talk to this app, and you literally designed it like you would design a circuit board, okay, by drawing components and lines between components, and then you hit a button, and it would materialize these various apps on different processors and hook them together with sockets, and boom, you'd have a running scalable application, because when you put the box in, you say, there's 1 to 8 of these, and you have one of these web-based applications. You come in, and the first thing that happens is there's this distributor that distributes the traffic out, and the distributor was one of their components, and it was all really fully automated data center of the future type stuff that right now people like Kubernetes and other folks like that are doing for container apps, and these guys were ahead of their time.
Oh, absolutely.
Right, in terms of both the idea that you needed orchestration and the model that they did, the graphical language for doing it, right? They having to do that shift, they decided they wouldn't go to VCs, that they would go to friends and family for their money, and we put some money in purely based on our impression that these guys were just super bright. And in fact, they succeeded, and they sold themselves to CA, and we got another big check.
Yeah, well, I remember that
very
very well,
satisfying.
and I actually got a little stock too, because I was on their advisory board, but I didn't make anywhere near what you did. But bottom line is that was very impressive, and one of the things that was really sad about that is the guy who was the CEO died.
He had a brain aneurysm,
Yeah, he was
and
taking a shower or something
dead
like that.
before he hit
died,
the floor.
Right.
And the
Just before the
and
they had the big
he
check.
was the spark plug.
Yes,
he was a super dynamic guy, gift of gab, very sharp technically, and he was the CEO, and he had a CTO. His name was Vlad.
Well, Vlad was the
Milosevic?
CEO, I think.
Milosevic? No, I'm getting
Vlad was the CEO.
right, and
That
Peter
guy.
Nikolov
Peter was
the CTO,
right.
and was very willing to sit back in the shadows and let Vlad go out and pound his head against the world while Peter came up with the designs. But when Vlad passed away, Peter, along with the executive chairman, basically took over management of the company and grew into the job, and became a good CEO
He
as
did a
well
great
as a
job.
good technical guy.
I can't remember his last name. His first name was Barry.
Yes.
Yeah, a very, very sharp guy.
Barry Lynn.
Yeah, right.
Barry Lynn.
And he had some money into it too. And
Yes, he was kind of a one-man VC.
he ended up selling it to CA, and we're talking now. When we sold it, I think about 5-6 years ago, something like that.
Yeah, about
Maybe a
that,
little more.
6-7 years ago.
But when they were first working on clouds,
I think CA ultimately drove it in the ground the way CA
Right.
does. But.
Yeah. But clouds in those days, when they were first coming up with these ideas, were pretty immature.
Yes.
People didn't really understand what a cloud really was in those days.
Right.
So this
Right.
they were ahead of the game.
Yes.
Did you
they
have
were.
anybody else that you want to talk about in that group of a dozen or more companies you worked with in those years?
Well, I mean, there were some of the people in Infusion. Bruce Thompson, who I thought was a really good guy.
Right.
He came from a NAS background, and so he and I, between us, I covered all block storage and didn't know a lot about NAS. He knew a lot about NAS. Had done some implementations of file systems, had done implementations of servers, and so we complemented each other really well on the technical stuff. Plus, personally, we got along really well. There was this guy, Tom Burniece, who I used to get along with.
Well, we got along pretty good
We
together.
had,
In fact, the
we
three
had
of
one,
us did a lot
we
of
had one
things together.
assignment that we got, which was it Quantum was getting rid of their portfolio?
Yes.
Some vulture capitalist was
Yes.
buying it from them.
And you and I did due
we
diligence
did
on
due
about a
diligence
dozen
on-
different
on
projects.
a dozen,
they had
on a
invested
dozen
in.
companies in a couple of weeks,
Right.
right? Which was
That was a very interesting.
quite an ordeal, actually.
Yeah.
And it makes me wonder whatever I should look up those companies and see what our predictions were and what actually happened.
Well, I do remember, and I can't remember the name of the company off the top of my head, was a large venture capital company that was going to buy this and wanted us to do due diligence on quantum. We're doing due diligence on the quantum portfolio for a company that was one of their potential buyers,
Yep.
and we basically gave them a very low price is what they're really worth. We came up with a value that was much lower than quantum was expecting.
Right.
And these guys actually bought it for less than that and did very well, I think.
Yep.
Return, but quantum went completely out of that business.
Yep. But being a consultant, I mean, it turned out this came at a good time. Ellen and I had talked this over, and we had just completed this heavy duty run of being first the mom and pop shop at Digital and having our calendar booked way in advance, and then at Compaq, still a certain amount of that. Compaq did not like the optics of a couple traveling together, and they actively discouraged us from doing that. So I did a lot of my evangelism, kind of on my own. And as I said, I was doing a lot of evangelism, which is a lot of travel and stuff. And the idea of being able to step back and trade money for time, right? To say, I'm not going to take this assignment because I'm on the beach, right? Was very attractive to both of us, right? Because we're getting on, and we're in our 50s, and it was nice to have time when you had the ability to do stuff with
Well,
it.
you guys, as I recall, for at least most of the last 20 years, have spent July on the beach.
Yep, and we
East
still
Coast.
spend a chunk of that, July into August now. So one of the things that we did take though was the CTO of Brocade, a guy named Kumar Malavalli.
Right.
After Brocade went public, he kind of broke off and had a ton of money. And one of the things he wanted to do was get some high-tech industry rolling in India.
Right.
And so we actually accepted two kind of assignments from him where we would go to conferences that he created in India and talk about the storage industry, storage technology, et cetera. And we didn't take money for it. We were paid in a business class ticket around the world, right, for the two of us. So we turned that into a vacation and got to, at the time, had a sister who was living in Ho Chi Minh City in Vietnam. And
Oh, I
so,
remember that.
we'd go and spend some time in India and visit my sister in Vietnam, and we went to Burma, and we did all this. That was our speaking fee, was the airfare, because it was it was a significant amount of money actually, and it wasn't something we might have done on our own, but it got us to all kinds of good parts of the world. Plus, we got to teach, if you will.
Well, Kumar's a really wonderful guy. We've actually done an oral history interview of him.
Oh, good.
So you can look it up.
Good.
So that's been published, and he's a great guy, and he's still very active.
Yes, he still has
He's got a
startups.
couple of
and-
companies. He's
Right.
done very well. He sold a couple.
Right. I know one of his companies. He has a disaster tolerance software company that some of the people I know in the industry bundle their software with the hardware that they sell. So yeah, he's doing okay.
All right. Well, I want to make a transition to kind of the last piece you've been involved with, but for quite a while, for the last few years, almost 100% of your time, and that was precipitated by one of the guys that worked for us at DEC. In fact, he was a young guy that had just earned a couple of years before I moved in there, by the name of Steve Sicola,
Right.
who eventually became your replacement when you moved on as CTO.
Yes. So when I left
Compaq.
Compaq as CTO,
Right.
he got the CTO job.
And then when HP bought Compaq, they didn't give him that job, so
Right. So
He
what
quit.
happened was
Tell him that.
Steve Sicola went to Stanford,
Right.
and his roommate, I believe, in Stanford was a guy named Steve Lusso.
Yes, he was.
And they would party together and hang out together and became very good friends. Steve Lusso went on to be the chairman of Seagate,
and CEO.
And CEO of Seagate for a while. I mean,
Yeah,
and I
that's
think
the chairman now.
he was
CEO
kind of a
first.
financial wizard, and he was the guy responsible, I think, for the strategies that took Seagate private and then public again, and
Yeah, actually, just to backfill that, the key thing is Al Shugart knew he'd have to have some software for Seagate. So he hired this banker by the name of Steve Lusso to build a software company for him. And he built it out of pieces, and it became Veritas.
yes,
And Veritas became more valuable than Seagate,
right,
even though they owned it all. So they basically created a way to be able to spin Veritas off to the shareholders to take Seagate private
right,
in about the year 2000.
yep,
And Lusso did all that.
right. And
as
so
the CEO.
Lusso, for years, starting back at in the 90s, would be talking to Steve Sokola as a friend and say, are you happy? Because if you're not happy, I'll set you up. We can do some stuff at Seagate. Steve's a very bright guy. Steve Sokola. Lusso
Steve is
also,
essentially
obviously.
a genius. He's very smart.
And Steve would say, no, I'm happy here. I'm doing interesting stuff. Steve was one of the linchpins behind the virtual controllers that we were doing, and had his finger in a lot of irons. And then when we went to Compaq and I left, he became the CTO for storage at Compaq. And whenever Steve Lusso called him, he'd say, no, I'm happy. And then HP bought Compaq, and Steve was not the CTO for storage at HP, and was doing some stuff. And again, there was this cultural conflict between the Compaq folks and the HP folks who had their culture and their way of doing things. And Steve Lusso called him up and said, are you happy? He said, no, I'm not that happy. So Steve Lusso said, all right, no problem. And this is shortly after the HP takeover. And HP did one of these stupid moves that big companies do. And they did one of these SERP, Senior Early Retirement Programs, to get rid of the engineers with all the experience because they had the highest salaries.
Yeah, they worked there like 10
like
years.
They weren't
whatever,
worth it.
They could retire.
Right. And so, if your age and years of service added up to
Some number,
55 or 65, you could qualify for this program and you get a big bonus to leave. So a whole bunch of digital engineers.
And turned to be the core of the HSC team.
The core of the new virtual controller team.
Yeah, and
was
also
named by
HSC
one-
guys,
Yes, and with the heritage back to the StorageWorks and HSC folks, because we had a very low turnover at Digital. Took a big check from HP and walked basically across the street and joined the Seagate Advanced Development Group. Right. And of course, I at the time was a consultant in the industry, and they became one of my clients, not through infusion, again, through just a private relationship. And so for a while, I would just come in every once in a while and listen to their plans and make comments on it. This is at the time I was heavily involved in EqualLogic. I had to definitely firewall what I was talking to XIO about and what I was talking to EqualLogic about.
Again, you just said XIO, which is the new name of it.
Right, sorry, when I was talking to the
Seagate.
Seagate Advanced Development people.
But talk about what they're trying to do, what they call the integrated storage element, the ISC.
Right,
That's what they're trying to
so Seagate was in the disk business,
do.
and disks were very low margin, and they wanted to move upstream and get more revenue, but they didn't want to go into the controller business, the standard storage controller business, because their customers were in the controller business. And you don't compete against your customers because they'll find some reason to go somewhere else, to buy their disk drive from somebody else, right? So instead, their idea, which was not actually the greatest in terms of business, the technical implementation of it was quite good, was what if we built something that had the characteristics of a disk drive, right? It looked like a disk drive and was a sealed unit, so it didn't have the replaceability of a storage controller and the expandability of a storage controller, but inside of it, there was a storage controller and enough spare storage so that you could turn this thing on and it would be very high performance because of the many disk drives that were inside of it. You could play games with the packaging that you couldn't do with removable packaging. You could bolt the drives down, which made them less susceptible to interference from the drive next door, because when a drive seeks, it's like a little earthquake going off. And there's a famous video out on the web of some guy walking over to a rack of storage and screaming at the disk drives, and all of a sudden their performance goes to hell because just his voice was enough to throw these drives off track. So instead you bolt the drive to a big hunk of metal in the controller, and that stuff doesn't happen. And because again it's a sealed unit, you have total control over the drives that are in it, how you do things, and they were able to get significant performance gains, plus the fact that there were 20% extra drives in there to cover failures, and those 20, until you got the failures, those 20% of the drives improved your performance. Instead of spreading the data over 8 drives, you'd spread it over 10. Instead of spreading data over 32 drives, you'd spread it over 40. So, pardon me, it's 25% extra, 20% of the capacity. So it was a nice idea. It was Steve's idea, Steve Sokola's idea. And the problem with it was that even though Seagate said, oh, this is just a disk drive, this goes in back of your controllers, all of their customers, EMC and HP and HP and IBM, looked at it and said, no, this is just a way for you to take money from our pocket and put it in your pocket, because you're doing some of the functions that we would normally do. And in any case, we can do it better than you because we know all the secrets and our people are excellent and blah, blah, blah. And so they never really sold, they never really had a significant OEM partner. They had a couple of second-tier OEM partners, and not very many. They spent a long time chasing NCR, which was not really a storage controller company, but used storage in their products and had some very dedicated kind of products they sold into the banking industry that did databases. But they ultimately didn't get that, and so the product eventually failed as a Seagate product. Okay, because Seagate couldn't sell it to end users. They'd be competing with their customers. They had to sell it to OEMs, and the OEMs weren't biting. So what happened was XIO, which was a kind of long in the tooth,
it was actually Xiotech
storage company. It was called Xiotech. It was a Minneapolis storage company that, in fact, was built to do virtual storage.
They were one of the early virtual
They were one of the
players,
early
right?
virtual storage plays. And they had an interesting architecture. It was advanced in some ways. They never figured out caching until very late in their term, but they did figure out how to get the reliability right, and they even had some distance mirroring and things like that. They offered to buy Seagate's Advanced Development Group for a song, for probably 15 cents on the dollar based on what Seagate had already poured into it. And the good thing about that was they didn't have the constraints that Seagate had. They could sell to end users.
Right.
So they basically bought the product, repackaged it as an end user product, which involved adding a bunch of things, because when you're an OEM, you rely on your customer to implement some things. So there was a scramble to get some other functionality in there. And they also, now, they had engineering management in Minneapolis, but they didn't really have engineering management in Colorado, and Steve, for all his strengths as a technologist, is not a manager. So they brought in Ellen Lary as their VP of engineering.
And general manager.
And I had started consulting with them, as I said, on an on and off reviewing basis early in their lives.
Well, you did it continuously all through as a consultant writing.
But then, when they got serious about implementing, they needed somebody to write code for this very bizarre chip that they were using as the heart of their controller, which they got from another storage startup whose name is flown out of my head, but it'll be in the transcript. This was a chip that had, again, kind of like the chip that I helped design for the BI controller at Digital. Had great data moving capabilities and kind of weird arithmetic capabilities, right? It was a...
Was that Aristos Logic?
It was Aristos Logic, yep. It was it had a whole bunch of little RISC processors in it, but it had real trouble accessing memory outside of the chip. Memory was like a peripheral. So in order to communicate with it, it was complicated. And you could not write a high-level language for it, so it had to be programmed in assembly. So I wound up being a coder, for them, a high-level coder. Right? And I had to modify my consulting contract because I had this obscene daily consulting rate that I charged. And so I would actually, and that consulting rate, I mean, I was worth it based on the fact that it was a fast study. And you could throw stuff at me and I could come up with a coherent response to it. But if I'm coding, I'm not worth that. So I had a consulting contract that said in any quarter, the first couple of days of the quarter, I was paid at my consulting rate. And then the rest of the quarter, I was paid at like 5/8 of my consulting rate. I called it undertime. Okay, because it's the opposite of overtime, right? Because I was worth less to them, as an implementer than I was as an idea guy and a networking guy and the industry's going this way or are you going that way guy, you know. So and I wound up coding up a significant fraction of the code that ran on this Aristos logic chip for him. So I was kind of deeply involved with them. And then all of a sudden, here comes Ellen, and as a consultant, and here comes Ellen, and she's the VP, and I'm working for my wife again.
What year was that approximately?
Let's see. It's a good question. I got to work backwards. It was about 2006 or so, or 7 that Ellen came in.
That'd be about right. Okay.
Right. So, and the other thing that was nice about XIO, well, first, you know, they wanted a lot of my time and they were willing to pay for it. Second, they were in the neighborhood. I didn't have to get on a plane.
Yeah, they basically consolidated in Colorado Springs, right?
It very quickly devolved that the Minneapolis group was in charge of the legacy Xiotech products and maintaining them and enhancing them, and putting the Seagate box in back of them. In other words, actually implementing the Seagate strategy was to put this enhanced ISE, intelligent storage element, you know, big, fast, smart disk drive, big, fast, smart, reliable disk drive, in back of some of their more mainframe-ish storage offerings instead of handling disk drives directly. So they were in charge of that, and we were in charge of developing the ISE as a consumer product, and we were basically considered the future strategy, and they were the rear guard. They were doing the rear guard operation of keeping the sales up while we did that. I had something, I was going somewhere. It doesn't matter. The other reason that I was at XIO was it was like old home week. Most of the guys there, and this slowly decreased over time, but some of the really heavy hitters from the digital storage group, the implementers, the guys who made the HSZ40 and HSZ80 work, the guys who then made the virtual storage controller work, were re-implementing their ideas, hopefully better and faster, at XIO. These are people like Clark Lubbers and Mike Walker and Susan Elkington and Randy Roberson. There were a whole bunch of
old friends.
All my old friends, and so it was like I was culturally compatible, with these guys, and when I talked, they listened, and when they talked, I listened, because each one of us we both had already proven ourselves to each other, and it was a good team, right? As time went on, they brought in a bunch of outside people who were actually their quality was quite good, and the culture changed from being like a DEC spinoff to having its own kind of startup culture. And remember, Xiotech at the time was had been in startup mode for probably 5 years.
Oh, I think
it was already a long.
I think it was started longer than that. I think they go back at least 10 years.
They go back to like about 2001, maybe, right? 2000, but we were the fresh blood at Xiotech. We had one or two people come over from Minneapolis, and they just became part of the group. And so it was fun as well as being challenging and lucrative. And so I wound up spending a lot of time with them as a consultant. And then at the beginning of, I think it was 2008, I'd have to go look it up. At the end of 2007, or so, we needed to go out for a funding round And it was right around the time, and so this is the way we'll find out what year it was, that the financial crisis hit.
That's
And
about 2007. yeah.
Seven, right, and funding
Yep.
dried up. Okay, and so the company had to undergo a contraction. And Ellen, and she'll get into this in more detail, had to lay off about somewhere between a third and a half of the people in Colorado Springs. And she put herself on the list as well because if we were going to be that small, we didn't need our own VP of engineering. There should be one VP of engineering to run the company from both locations, and she was willing to give that up. You know, she was getting on at that point. So she departed, and the smaller group continued on. We had already at that point announced the product and had revenue coming in. Ellen had gotten the first generation product out the door. But shortly after Ellen left in about November of 2007, and in January 2008, I was diagnosed with colon cancer.
Right.
And so I basically stopped doing any work while I dealt with surgery and radiation and chemo and whatever else it was. And during that time, I noticed that when I was sitting at home recovering, that there wasn't any money coming in. Because I was a consultant. This is the downside of consultancy. You don't work, you don't get paid. And probably people at XIO, at Xiotech, figured that out too. So when I actually got back to the point where I'm saying I'm ready to go, Steve Sokola and the then CEO of Xiotech, and I forget because we went through CEOs.
You did a half a dozen
like,
at least, yeah.
Right, like a knife through butter. Took me out to dinner and pitched me on becoming an employee. Right, and I was in a state where I was receptive to that, having just gone through 6 months of no income, and I said that's cool, but being a consultant, I'm used to having a lot of free time and being in control of my free time. I said, make us an offer, and so I became a full-time employee of XIO with 17 weeks of vacation a year.
Yeah, well, I remember when that happened. That was amazing.
And I took a pay cut to get it, and it was worth it, because it let me have my cake and eat it too. I was an employee. I had guaranteed income in case I got sick again, which I did. I relapsed after about 18 months, and that was very scary. And here I am.
And the good news is you're completely over it right now.
And I'm over it. I've gone through I've passed the 5 years on the relapse and all that. So that kind of further cemented me to the company. They weren't just a client, they were my employer, and I had stock options, and my success was tied to theirs. We did fairly well with the product, but ultimately never really achieved escape velocity. And at some point, when you don't achieve escape velocity, you need the capital infusions that you're looking for. Everybody gets diluted further and further, and it doesn't look attractive. And so about 2 years ago now, the company folded. Okay. By this time, it had
in the meantime, they had
rebranded itself as XIO,
XIO, right.
because the rear guard, having fought valiantly, there was no sense them fighting anymore. They were milking an ever-shrinking customer base. And we just kind of turned them into a support organization for the old classic customers. And because money was tight. So we rebranded ourselves as XIO. We went through another CEO or two. And eventually got a guy named Bill Miller, who I had known in the past because Bill Miller used to run Storage Networking, which was the first kind of storage as a service. Rent your storage.
In fact, it was one of your first consulting clients.
And they were Compaq was an investor in Storage Networks, and Storage Networks allowed Compaq to put somebody on their advisory board, and Compaq picked me. So in fact, when I left Compaq, Compaq didn't remove me from their, Storage Networks didn't remove me from their board. In fact, when Compaq put me on the board, I was already a short timer at Compaq, and I went to one of the people, at the senior executives at Compaq, and I said, not that I don't want to do this, but are you sure you want to put me on the board when I'm going to be leaving the company in a couple of months? And they said, everybody announces when they put somebody on a board. Nobody announces when they take somebody off a board. He said, we'll get our PR from the announcement that we're putting you on the board, and then, yeah, you could just vanish. But it turned out StorageWorks, kept me. So I knew Bill Miller. I admired Bill Miller, and he became the CEO, and he still is, right? But the company did run out of money and technically die. However, we had enough of a customer base that the corpse was able to keep itself going on support revenues. And then Bill Miller found some more investors, and we started up with a very small engineering group. Meanwhile, I was getting old, right? I'm going to turn 70 in a month, and I seriously considered just okay, that's it, time to go and pick up a hobby or something. But before that, we had decided to, because we were getting into flash storage, and everybody in flash storage was implementing deduplication. And so I started giving deduplication some thought, and after a while came up with a couple of ideas that I thought were neat and nobody else had done about how to implement deduplication, and presented them around to people at XIO, and they said, this is great, let's go run with this. And they put a bunch of people on the project, and we were off building a system that would be all solid state disk and implement deduplication. And then the company folded, and then a couple of months later kind of got reborn, and I had a chance to bring my baby to term, right? So I decided to go back and rejoin the newly reborn XIO, and in fact, about 4 or 5 months ago, we shipped a product that does deduplication.
Is that the one that's called Igloo?
No, it's called it's called some horrible name like the Ice 4.
Oh.
Right? But it's an all solid state disk product that implements deduplication and has reasonable performance and great kind of performance for the amount of dedupe is very CPU intensive and very memory intensive, and a lot of the people who have implemented successful dedupe solutions have thrown immense amounts of CPU power and immense amounts of memory at the problem, and we actually have achieved pretty good dedupe performance with a modest amount of CPU, a single 4-core processor, and a modest amount of memory, as opposed to 8 cores and 256 megabytes of memory to do it. So in that sense, it's been successful. We'll see if it's going to be successful in the market. And I got to bring my baby to term.
And
now I got to figure out what's
of the
next.
ISE at all. It really is a completely different product.
Well, it does handle it. It's based on the ISE code.
Oh, is it? Okay.
So it does have the characteristics of the ISE, except that in our reduced state after our death and resurrection, we didn't have the hardware engineers to build a next generation storage platform. So we actually OEM the storage hardware.
Okay.
From I'd probably say it from San Mina, which is a good, and in fact, actually, it traces its legacy probably back to Ruben Martinez, who was at San Mina when the box that we're currently using
and was one of your key guys at Tech when
was
you were
conceived
doing
and was one of the
storage.
storage. Everything comes around, right? Yeah, and so that's where I am now. Right now, we're working on again an interesting next gen kind of product that I can't talk about, but it's given us a chance to escape that brand new wonderful design that we did in 2003 and 2004, which is now an old crufty spaghetti coated design, right? And with a bunch of obvious software flaws in it, and start something from complete scratch and implement a whole bunch of new software flaws, which aren't obvious to us now, but will be in 5 or 10 years. And so that's actually fun, and I've been putting in, when I rejoined the company, I rejoined them on a part-time basis. I'm an hourly employee.
Okay. Hourly
with
employee.
undertime. Okay, but I've been working basically 3/4 time. I've been working much more than I expected to because it's fun building something from scratch.
Fantastic. Well, I'll tell you what, I think we're pretty much caught up. We got a few more minutes. Is there anybody else that you haven't mentioned in both these interviews that you
dozens, I'm
want to
sure.
bring up, and talk about briefly why you admired them or why they were a significant influence on your life or somebody that was really a great person to work with or whatever? Go ahead and do that.
Wow. We covered a lot of ground. When I was reviewing the notes, I noticed I attributed VMS to two people, to Dave Cutler and Dick Hustvedt.
Right.
There was a third guy, really, named Peter Lipman, who was a major contributor to VMS. Didn't have the visibility of
Well, Dave and
Dick.
Hustvedt are more managers at that point, right? Although
They were more project leads. In other words,
Okay.
they weren't managers that did budgets and managed people. They were technical managers,
Yeah, right, okay.
right? They governed, and in fact, Peter Lipman was also, I believe, in that role,
Oh, was he?
and was in charge of things more like the file system and a lot of the some of the user visible, the UI and things like that, right? But he deserves to be in that group.
Yes.
I don't think, talk about Steve Sokola that much at.
Other than we just brought it up, I think.
Right, I talked about him kind of post-digital,
Right.
but in fact, he started off as a diagnostic engineer.
Yes, that's what he was when I joined the company.
At a fairly low rung.
He was right out of college.
And immediately started kind of innovating the way diagnostics got done in the controllers, and the way they did their self-test, and then worked his way up into doing the functional code, and then into design, and ultimately into the kind of product definition stuff that he was doing at Xiotech, or Seagate, really.
Well, it's my understanding he also had a lot of responsibility and influence on the way they finally got the CI function to completely work.
Not so much CI, but he noticed early on when we were getting into Fiber Channel that Brocade appeared to be the technical leader
All right.
in Fiber Channel stuff. And so he wound up being our liaison to Brocade, who valued him enough that they actually gave him friends and family stock, which caused some issues at Digital, like can a Digital employee accept friends and family stock from an outside company? But they weren't a competitor. It was a symbiotic relationship, and ultimately they let him do it. So in terms of the integration of our initial because Fiber Channel was a bunch of guys wandering around in the dark hoping they made contact. The spec was there, but it was subject to multiple interpretations and stuff like that. So the integration of our Fiber Channel products with the Brocade switches and through the Brocade switches with the host adapters was a major piece of work and it's kind of techno-political work, right? That Steve took on himself and executed.
Well,
really
plus he
well.
brought obviously then brought his knowledge of how the CI actually fundamentally worked, because a lot of that stuff I think got played into that.
Yeah.
Right?
Yeah, exactly.
That was the first thing.
Well, Steve came in knowing
Right.
how you build a real reliable system at the system level.
I mean, in a certain
Brocade
sense,
was building a switch.
yeah, in a certain sense, the HSC was a switchless SAN.
Right.
You
It
call it
was.
a cluster.
The HSC
And,
was, as far as I know, the
Brocade
first
was a
really
switch SAN.
network storage device.
Right.
We ran over a real network.
We had a passive hub.
And it's nice to have looked back and said we did that. Of course, now network storage is on the decline. I just read that it's actually volumes revenue for network type storage, block storage is declining. Server attached storage. This is the wheel of reincarnation in the industry.
Oh, and Steve was working on some stuff that he thinks is going to go right back to that.
Yes, he's
Fundamental stuff.
involved in a startup in New Jersey right now.
Yeah, really interesting. Yeah, actually, in a couple of them.
And in fact, the project that we're doing from scratch is actually not a pure storage play. It is, I can't talk about it, but it's working in conjunction with a large company to do a particularly interesting form of hyperconverged
Well, we'll bring you back on
storage
your
and
on
computing.
your on your 80th birthday and see if we can
Right.
find out what happened. So, anybody else you want to mention?
When the door slams on my way out the door, I'll come up with a dozen names,
Right.
but right now I'm clueless.
So, you look back on all this. What are you most proud of? Of all the things you did, what do you really feel was really your most proud moment?
Well, I think I said in the other interview that of all the things I did at Digital, the thing that I was most proud of was the Scrabble playing program.
Yeah, well, that was a good one.
And there's truth in that because it was completely radical and different
Right.
from everything else I did.
And that's when you're programming the computer in originally back in Brooklyn's Public, right?
Huh?
That started there. Right?
Well, no, that started
Oh, was
in
that at
that started in the early '70s at Digital.
So it's
Me
at
and
that,
Stan
okay,
Rabinowitz
all right,
deciding that people had been doing chess and checkers, but nobody had really attacked Scrabble, and it was very different. It's not a pure strategy game. It's there's word making, and we actually bought a Scrabble dictionary and ripped it into 20 sections and had us and 18 of our friends type it in.
Okay.
But it was the result was so good and it was such a hack that. No, I'm really proud of the first digital storage architecture because I was really a linchpin of that, and it came off the digital storage architecture, and it came off really well. And more recently, I'm pretty proud of this dedupe thing because my partly because of the job that I was in, and partly because of the opportunities, my inventiveness output, you can measure it as number of patents or just number of times that I finally look up on a piece of paper and go, shit, that's neat, right? Had gone down, and so it was nice to be able to kind of pull it all together and actually come up with something innovative.
Well, plus dedupe has been around now for over 20 years. In fact, you worked on one of the early ones as one of your consulting jobs.
Yep.
Yeah.
Yep.
And it started with a Z.
Avamar was did
Yeah,
dedupe
before
around
they had
backup.
it had a different name. Started with a Z, but became Avamar and got bought for a lot of money.
Yes.
Yeah.
Yes.
Yeah, and that was that was 20 years ago. That was on 2000, 2001.
Right.
When we were consulting.
Right. But they were doing it for backup.
Right.
In fact, at one point.
Well, actually, we talked them into doing it for backup.
At one
that was
point,
not the original plan.
At one point, after EqualLogic had sold, I got a call from Paul Long, who said, I'm looking at another startup, and it's to do real-time data reduction. And I said, that'll never work. It's way too compute intensive and way too storage intensive. You'll bring performance to a halt. And in fact, when she said it, that was true because she was looking at doing it on hard disk drives.
Yeah.
And then Flash came along, and it wasn't such a bad idea.
That's a good idea, actually. Well, any other comments you want to make for the end of this?
No, I'm good.
All right. Well,
Thanks
really,
for giving me the opportunity to babble.
really well. I love listening to you babble, to tell you the truth. But bottom line is, it's been an honor having you here, and maybe we'll have that third deal in about 10 years and figure what happens next.
You never know. At one point I keep saying I should just give this up, but it's fun.
Yeah, it is fun.
And I'm still competent at it. I mean, by today's standards, I'm not a very good coder. I don't write code the way I used to, and I write nice, neat, compact, good-looking code. But compared
we
to
talked about
these
this.
young whippersnappers, I'm old and I'm slow.
We talked about this earlier, but your key thing when I joined the company, Dick, that is, and Gordon Bell started talking about you, is you're the chief fireman. You go out and fix somebody else's code and do it very quickly.
And in fact, to be
did
honest,
a lot.
if I were to stop doing this kind of building products for a living, one of the things I've thought about is, kind of putting some feelers out and saying, if you have a piece of code that's old and bloated and doesn't work very well anymore, I'd be willing to do something on spec where I just go read your code for a month and then make some suggestions
You
and
definitely were
maybe
good at
implement
that,
some
no
of
doubt
them
about it.
because that would keep it interesting.
Yeah,
Huh?
well, that'd be fun.